So to recapture page 38, basically what they're saying is that biologists use proportions in order to solve and try and figure out how many animals are living in a specific area. This is the example of the proportion that they use, and in this example, they usually do the first catch here on the left and the second catch here on the right. Okay, they do the tagged over the total in both cases. Again, tagged, and then this is the total of the second catch. So in the example that they give, they said that they had originally caught and tagged 24 sharks. We're always looking to find the total number of sharks in an area, so for now we're going to keep that as X. And then the problem says that the second time around they caught 80, which would be the total. And then only 8 of them were captured. Or tagged, sorry. Then you can go ahead and solve for your X variable. Okay, we're working up because 24 is bigger than 8, so we multiply. You need to go through and figure out how many total sharks are in this area. You should have found that there are 240 sharks living in that area. All you had to do was multiply the top by 3, 8 times 3 is 24, and multiply the bottom by 3. 80 times 3 gives you 240 sharks. For now, I'm going to have you skip all the way up until page 40 on problem number 5. It says, wildlife biologists tag deer in wildlife refuges. They originally tagged 240 deer. That would be the first time they went out tagging animals, and they tagged 240 deer. We're going to be looking for the total amount of deer, so we leave that as X. And then the problem goes on to say the next month they observed 180 deer. So that's the total that they caught was 180. And of that total, 30 deer were tagged. So you need to go through and solve. How do you work from 180 to X and 30 to 140? If we're getting bigger, we need to multiply. You go ahead and solve, and then when you're ready, press play. You should have found that if you multiply 30 by 8, you get 240, and if you multiply 180 times 8, you should get 1,440 total deer living in that area. Problem 2 on page 41, you should see a girl standing at the bottom of the page. She's saying that the Ready Steady Battery Company tests batteries as they come through the assembly line and then uses a proportion to predict how many of its total production might be defective. On Friday, the quality controller tested every 10th battery and found that of the 320 batteries tested, 8 were defective. If the company shipped a total of 3,200 batteries, how many might be defective? Well, if you flip over to page 42, both John and Matthew tried solving the problem. Here we have John, and he set up a proportion. 8 batteries were defective out of the 320, and if you scale up, he multiplied by 10 on the bottom, and then he's also going to multiply by 10 on the top, and he finds out that 80 batteries would be defective. If you look at Matthew's way of solving, he also found that 80 batteries would be defective, except he used colons to write his ratios, but technically he still ended up scaling up. He took 8 times 10 to give you 80, and on this side, 320 times 10 to get 3,200. Both ways are correct. Either one is totally fine. Whatever you're used to, whatever you're more comfortable with, works. Go ahead and check out page 43 with your table and try and figure out if their methods are correct or not. Once you have finished discussing Donald and Natalie's methods, I want you to go ahead and skip to page 47, problem 3. Number 1 says the school store sells computer games for practicing math skills. The table shows how many of each game were sold last year. How many total games were sold last year? Well, in order to figure this out, all you need to do is take each group of games and add them together. So go ahead and do that. You can use your calculator if you want to, or do it by hand, and then when you're done, press play. You should have gotten an answer of 400 total games. Part B says the store would like to order a total of 1,000 games this year. About how many of each game should the store order? Well, they had 120 Fast Facts games out of a total of 400. So I can just set up proportions with 1,000 as my total number to find out how many Fast Facts games I should buy. I'm working up from 400 towards 1,000, so I know I'm going to need to multiply. If I don't know what 400 times to get me 1,000 is, I can always work backwards, and I can take 1,000 divided by 400 to get an answer of 2.5. And then I can use that up on my top. Also, I can take 120 times 2.5 to get 300. So then I know that I will need 300 Fast Facts games. I'm going to set up the proportion for your next one. Fraction Fun, they ordered 80 out of 400. Now again, you're looking for 1,000 games. How many Fraction Fun games do you need? Well, our going between number is still going to stay 2.5. So we just have to multiply the top by 2.5 also. You need to go through and find out how many of the last 3 games they should buy, and then when you're done, press play. You should have gotten these answers for how many games they should buy if they wanted to buy a total of 1,000. You can always go back and check when you add them all up, do you get a total of 1,000 games? If you need to check your work, you and your group mates need to go back and check your work to make sure you're getting these answers as the correct answers. Part C says, if the store would like to order 240 games this year, how many of each game should they order? Well, in order to solve this, we're going to do the same exact thing we did. 120 games out of a total of 400. And then this time, they want a total of 240 games. You need to go through and figure out the amount of games they should buy for each 4 different kinds. And when you're done, you can press play. You should have gotten these answers for the amount of games they should buy when trying to buy a total of 240 games. And if you can want, you can do the same thing here and add to make sure that you get a total of 240 games. I would like you and your group to work together to finish page 47, and then go ahead and do page 48 and 49 also.